Let us start. So the next topic is calculation of correlation coefficient from regression coefficient. So here this is a mix of correlation as well as regression. So if you see the heading carefully, calculation of correlation coefficient. So we will be finding out R by using regression coefficients. What are regression coefficients? Bxy and Byx. These are regression coefficients. And correlation coefficients we already know, that is R or capital R. Okay, usually it is small r. So let us start. So consider both the regression coefficients Byx and Bxy. So we are considering both the coefficients Byx and Bxy. And what is the formula for Byx and Bxy? We saw different types of formulas actually, right? So here the formula which we are using here is different. That is nothing but R into. So if you go back, I think we have to go back to the starting part of regression. And if you see here, regression equations. And when we came to coefficients of regression equations, so if you see here, you have R into regression coefficient Byx. R is coefficient of correlation. So R into standard deviation of Y divided by standard deviation of X. This is what was the coefficient actual formula, regression coefficient actual formula. Excuse me. Similarly, when you take the regression coefficient for Bxy, you have R into standard deviation of X divided by standard deviation of Y. Okay, so this is the other original formula. So what we will be doing is we'll be taking this original formula and we will be applying that here to find the correlation coefficient. So Byx is equal to R into standard deviation of Y by standard deviation of X, and Bxy is R into standard deviation of X by standard deviation of Y. Okay, so the product of Byx and Bxy can be expressed as, so if we are multiplying both Byx and Bxy, then what is the resultant? So first if you take Byx into, if you put brackets, it is into Bxy is equal to, I will multiply, I'll multiply these two here. So first R into standard deviation of Y by standard deviation of X into R into standard deviation of X by standard deviation of Y. So I am multiplying. Now if you see here, this side Byx into Bxy will remain as it is. Okay, but if you see on the other side, standard deviation of Y will get cancelled. Standard deviation of X will get cancelled. Okay, since one is in numerator and the other is in denominator, we can cancel them. So what remains? R, and here also R will remain. So R into R will remain. So Byx into Bxy is equal to R into R is R square. Okay, now if I want to get this square to the other side, then what will happen is, the square is coming to the other side. If one side it is square, the other side it will become square root. Okay, so that is how I get R is equal to square root of Byx into Bxy. Okay, so how do I find the correlation coefficient using regression coefficients? I am repeating it again. Okay, I am repeating it again. Clearly understand. R is the correlation coefficient. Regression coefficients are Byx and Bxy. Regression has two coefficients, Byx and Bxy. R is the correlation coefficient. So we are finding correlation coefficient by using regression coefficients. So correlation coefficients here by using regression coefficients are square root of byx into bxy. Okay, so this is the first and foremost important formula that you have to remember when such problems are given. They can ask this for 6 marks. I mean, not the explanation of or this working. I'm talking about problems under this. They can ask for 6 marks. Any doubts until here? Did you all understand? Very easy. Sometimes they'll give you very easy questions and ask for 2 marks also. That also can be done. Okay. So let us read further. We have few more important points to understand. Thus, from the above, the correlation coefficient is the square root of product of two regression coefficients. Now, this they will give in the statement problem. Read this line carefully. Correlation coefficient, that is R, is the square root of product of two regression coefficients. Square root of product of two regression coefficients. What is regression coefficients? Byx and bxy. Okay, so they, in a statement question, they can ask that, or they can also give this statement. The correlation coefficient is the geometric mean between the regression coefficient. So in a question, they can give the geometric mean between the regression coefficients is, that also can be the line. So it is the geometric mean between the regression coefficients. Now, how do we find geometric mean? We find it in the same formula, that is square root of one coefficient into the other coefficient. Now, there is some word of caution. There is some warning given to us, which we have to keep in mind. So let us see that. Since the values of the coefficient of correlation are cannot exceed plus or minus 1. So if you remember in correlation, we were doing this timeline where we told the value should be between plus 1 and minus 1, and you have a 0 in between, and then we will doing. So which means the R value should be in between plus 1 and minus 1. Okay, so since the R value should be in between plus and minus 1, so one of the regression coefficient must be less than 1. So if you want to find R, the one of the, no, I'm not saying 2. If both are less than 1, good. But at least one of them should be less than 1. If the other one is more than 1 also, it is fine. But one should be less than 1. That means both the regression coefficients cannot be more than 1. Okay, that's what they're saying. So you cannot even have one of them more than 1. Okay, both the regression coefficients, the byx and bxy, should be less than 1. 0. Let's say 0.23. Okay, both byx and bxy should be less than 1. Only then you will be getting the correlation also less than 1. Keep this in mind. It's very, very important. It has to, the values, or simply keep this in mind. All the values, correlation, regression, all the values should be less than 1. Okay, next. Next word of caution. Both regression coefficients shall have same sign. Okay, so both yx and yxy must have same sign. This is the next rule. Then only R will have the same sign. If regression coefficients have different sign, R cannot be computed. So did you all understand this? One cannot be plus, one cannot be minus. Both has to be plus or both has to be minus. Okay, now here they have just given the example. Okay, minus 8 into minus 2 because we are finding square root. Minus 8 into minus 2, 8 2s are 16. Minus into minus is plus. So square root of 16 is plus or minus 4. Okay, and if you have the same 8 into 2, both are plus, then also you will get the answer as plus or minus 4. Okay, now suppose if one of the value is minus, then you will get minus 16. Square root of minus values you cannot find, it will show you error. You can try it in the calculator. Negative sign with the square root, it will not calculate the values at all. So you have to be careful in checking the numbers also. You can check in the calculator, it shows error, minus 16, minus 9, anything you can check. Square root of minus 9 you check, it will show you error. So you cannot calculate the minus values. So therefore, both the numbers have to be either minus or it has to be plus. Both the numbers. Only then you will get the proper answer for correlation. If one is minus, one is plus, then you will not get the right answer. You cannot derive the answer. So did you understand both the cautions, both the warnings? What is the first warning? First warning is all the numbers byx, bxy are, everything should be less than 1. Okay, less than 1. It should be between plus 1 and minus 1. So it should be less than 1. And the second word of caution is both the numbers should have same sign. You cannot have different sign. Understood? Any doubts until here? Can we go to the problems? Okay, then let's solve the problems. Very easy problem here. They can ask this for 2 marks. Okay, I've seen lot of problems that has been asked in the 2 marks in this section. Okay, so let us see. Calculate R if bxy is equal to 0.8 and byx is equal to 0.96. So first let us check the warnings. For what is the first warning? Both xy and byx should be less than 1. Are they less than 1? 0.8 is less than 1. So okay. 0.96 is also less than 1. So okay, no problem. So the first warning is okay, no problem there. Now coming to the second point, we have to check if both have same sign. Okay, same sign. Now here both have plus sign. Here both have plus sign. So again, second point also is compiled with. So both the points are done. Now let us solve. We have to find out R when bxy and byx is given to us. So very, very simple. Square root of bxy is 0.8 and byx is 0.96. So you get square root of 0.768 and then the value of R is 0.876. This is the correlation value that we get. In simple ways, this is the correlation value that you get. Okay, just multiply both the numbers given and you'll get the answer. Fine? Understood? Any doubts in the first problem? Now moving on to the second problem. Here again let us check the 2 points. The first point is it has to be less than 1. So less than 1 means 0.36 is less than 1. Okay, but the other number is more than 1. Okay, so we are taking a chance. Let us see if sorry, this is also less than 1. How? It is minus 1.38. It is not plus 1, right? It is minus 1.38. So it is less than 1. So we can consider. Then second point, are they of same sign? Are they of same sign? So if you see here, here also there is minus, here also there is minus. Okay, now coming to this part, square root of bxy into byx minus 0.36 into minus 1.38. When you multiply these two, you get 0.4968. Now here it is not technically minus. According to maths, this is plus. Okay, according to maths, this is plus because minus into minus is plus. Because I told you, if you have square root and inside if you have minus number, then you cannot find the square root. Correct? So this is mathematically, this is plus. Just for representation they have given. Now if you find the square root of 0.4968, then you get 0.7048. Okay, but one thing what you will have to realize and understand is, since both the numbers were minus, the correlation coefficient will also be minus. Here both the numbers were plus, so that is why you have plus value. Here both the numbers were minus, so that is why you will also have correlation coefficient as minus value. Okay, so there is a note given. Both regression coefficients are negative, therefore R is negative. So did you understand the second question? Did you all understand this part? Any doubts here? Or you want me to explain it again? Everybody understood? Okay. Okay, good. Now, moving further, calculate, next problem, calculate two regression coefficients when. So here we are supposed to calculate the coefficients. So what are the regression coefficients? Bxy and byx are the regression coefficients. Correct? So we are supposed to find out these coefficients, and what is the information given? They have given correlation coefficient, that is R, and then they have given standard deviation of X and standard deviation of Y. This is standard deviation of Y. Okay, so we are going to use this formula. We are going to use this formula and this formula to find the value of bxy and byx. Okay, so let us use that. Now we know what is R, what is standard deviation of X, and what is standard deviation of Y. So first one, bxy is equal to correlation coefficient into standard deviation of X by standard deviation of Y. That is the formula. Now what is R? 0.9 into standard deviation of X is 10, standard deviation of Y is 1.5. Okay, now if you simplify this, you will get the answer as 6. So 6 is the answer. Just check this calculation once again. Are you really getting 6 here? Zero 0.9 into 10 divided by 1.5. Yeah, you get 6. Okay, so this bxy is 6, and let us find out byx. Just application of formula is what you're supposed to do. So for we found out bxy. Yeah, this should be byx. Okay, they've given it wrong here. Okay, this is y on x, and this should be byx. Okay, this should be byx. So what is the formula? R into standard deviation of y, 6.666. Okay, 6 is enough. Okay, no need of other points. Okay, so R into standard deviation of y by standard deviation of x, which is nothing but 0.9 into 1.5 by 10. So you get 0.135. So these are the two regression coefficients they asked us to find, and we have found the regression coefficients. Understood? Any doubts in this question? Everybody understood? Okay. Now, the next question. If one of the regression coefficient is 1.5 and R is 0.55, find the value of other regression coefficient. Okay. Now here they have not told if it is bxy or byx. We don't know which is 1.5. Okay. So we will assume one of it, because it's anyways multiplication. So they are saying us one of the regression coefficient. So I am assuming bxy is 1.5. You can also assume byx as 1.5. No problem. In both the cases, you will get the answer. Okay. If bxy is 1.5, if bxy is 1.5 and R is 0.55, so R is nothing but correlation coefficient is 0.55. We have to find the other coefficient. So here we know bxy, we know R. R is equal to 0.55. So let us find the value. So write the formula. R is equal to square root of bxy into byx. Okay, now square root of bxy is 1.5 and byx I will keep it as it is. And 0.55 is the value of R. So if it was square and if I take it to the other side, it will become square root. Okay, but if I want to take square root to the other side, again it is going to become square only. So what I'm going to do is I'm going to take the square root to the other side. If I take square root to the other side, it's going to become 0.55 square into 1.5 into byx. Okay, 0.55 square is nothing but 0.3025 and 1 second. Yeah, 0.3025 divided by 1.5. I get the other coefficient value, that is regression coefficient value, that is 0.2017. So here they had given us only one regression coefficient and we found the other regression coefficient value given the correlation coefficient is also given to us. So this is the next problem. Any doubts in this problem? If you want me to repeat it again any point of time, you can say so that I can repeat it. Because if you get confused here, there are chances of losing marks. Though it comes for 2 marks, they will surely ask one question from these regression and correlation coefficient. Okay, so please understand, if you have any doubts, do ask. Okay, next. Find R when two regression coefficients are 0.6 and 1.4. Now firstly, check the rules. Both are less than 1. Yeah, both are less than 1. 0.6 and minus 1.4. So both are less than 1. First condition, okay. Second condition, both have same sign. Do they have same sign? Both of them? One is plus and other is minus. Do they have same sign? No, they don't have same sign. Which means the second condition is not satisfied. So we cannot compute the correlation coefficient. Understood? That time you have to write, since regression coefficients are of different sign, R, that is correlation coefficient, cannot be computed. Okay, they cannot be computed. Did you understand? So checking signs and checking these two conditions are very, very important in each problem when it comes to using both correlation and regression coefficients. Clear? Now moving on to the next problem. If x is equal to 0.85y and y is equal to 0.89x, standard deviation of x is 3, calculate standard deviation of y and correlation coefficient. Okay, there's a lot of information. Let us understand one by one. If x is equal to 0.85y, okay, so they have given us one equation here and there is another equation, y is equal to 0.89x. Standard deviation of x is 3. So calculate standard deviation of y and r. So firstly, we will take this equation. This is nothing but x on y. Now when you have x first, it is x on y. When you have y first, it is y on x. So we have the regression equation given, that is x on y is x is equal to 0.85y. Now, if you remember, while we were solving the problems, the big problems with time series type of problems and all. So what was the formula for regression equation? X minus x bar is equal to bxy into y minus y bar. Correct? This was the equation we were using. Now, if you compare this equation with this equation here, x minus x bar, they are giving us one small x is equal to bxy. In the place of bxy, there is a number which says 0.85. And then again, for y minus y bar, you have y as the value. So from this, I can understand that this value in the place of bxy, I have 0.85, which means the value of bxy is 0.85. Did you all understand this first part? Did you all understand this first part? Yes or no? Everybody understood? Or you want me to repeat it again? Reply quickly. Okay. So since you have understood, I am not repeating it. Fine. Now let us go to the next equation, that is y on x. Now when you take y on x here, that is the next equation. Now y on x, how will you identify? First you will have y. Y is equal to 0.89x. So what was the equation for y on x? Y minus y bar is equal to byx into x minus x bar. So in the place of byx, I have 0.89. So I can say the other coefficient byx is 0.89. Okay, now I know the regression coefficients, that is bxy and byx. Correct? Now, this is one type of calculation. Now, another calculation which you have to do is the formula for bxy or byx using any of the formula. Sorry, yx. Now, what is the formula? R into standard deviation of x by standard deviation of y. You can use this formula also. First, you have to find out this, and afterwards, you have to use this formula. Okay. Now, let us see what will be done. Now, we know what is bxy and byx. So, let us find out r. First, we'll find out r. Now, to find r, we quickly know that square root of these two, if you multiply and find the square root of these two, you will immediately get the value of correlation coefficient. So let us do that. R is equal to square root of bxy into byx is equal to square root of 0.85 into 0.89, and you get the correlation coefficient. Now in the question, what all they had asked us to find? They had asked us to find standard deviation of y and r. So we found bxy and byx, and then we immediately found r. Now what else is remaining? Standard deviation of y. Okay, and what is given to us? Standard deviation of x is given to us. So now use that in this formula. bxy is equal to r into standard deviation of x by standard deviation of y. Now in this formula, we know all the numbers except standard deviation of y. Okay, so bxy is 0.85, r is 0.8698. Then standard deviation of x is given in the problem, that is 3 divided by standard deviation of y. Okay, and then now you have to do the simplification. So what they have done here is they have exchanged the places here, that's all. Standard deviation of y will go to the other side and 0.85 will come here. Okay, so 0.8698 into 3 by 0.85 will give us the standard deviation of y to be 3.0699. So we found the value of r and standard deviation of the y as per the question asked. So understood? Any doubts on this problem? Any part you want me to explain it again? Can we go for the next problem? Okay. Now this is a 14 marks question. This can be asked for 14 marks. Okay. So clearly listen. From the data given below, find the two regression coefficients. Okay. So what are the two regression coefficients? Say me, what are the two regression coefficients? Coefficients. B bxy and byx are the regression coefficients. Don't get confused. Okay, regression coefficients. Next, we also have to find the regression equations. Regression equations is x on y and y on x. Both the equations we have to find. Then what else do we have to find? The coefficient of correlation between the marks of stats and maths. So here we are applying both correlation as well as regression. Okay, we are applying correlation as well as regression. So we have to find out correlation between the marks of statistics and mathematics. And then the most likely marks in mathematics when the statistics is 30. So one can be taken as x, one can be taken as y. So they have given us x is equal to 30 and we have to find the value of y. So did you understand the question? First of all, you have to calculate the regression coefficient bxy and byx. You have to calculate regression equation, that is x on y and y on x. And then you also have to calculate correlation coefficient, that is nothing but r. And then they have given us the value of x to be 30 and we have to find the value of y. Okay, so this is all you have to find. Now coming to the data, they have given us marks in statistics and marks in mathematics. So let us assume or let us take marks in statistics as x and marks in mathematics as y. Okay, one of the data to be x and the other data to be y. Now let us see what all we'll have to do. Now since we have to calculate correlation also, we will first find out the arithmetic mean. Now by calculating arithmetic mean, we will be able to decide should we take actual mean or should we take assumed mean. So what is the condition of taking assumed mean? If your actual mean, that is x bar, if you get in points, then you'll have to take assumed mean. So here, yeah, this is actual mean, correct Akila. So here if you calculate the x bar, that is sigma x by n and sigma y by n, you have got the whole numbers. So which means this is an actual mean problem. So we are considering the actual mean. So what is the next thing we will do? We will find the deviations. So since it's an actual mean problem, we'll find deviations from x, that is x small x is equal to x minus x bar. What is x bar? X bar is 32. So 25 minus 32 is minus 7, 28 minus 32 is minus 4, 35 minus 32 is 3, 32 minus 32 is 0, and so on. You have to find the deviations from x. Similarly, find the deviations from y. What is y bar? Y bar is 38. Now from y take the deviations. 43 minus 38 is 5, 46